Good morning to everyone. I had a request to do number 20, so I'm going to do that now. And I just realized um, I'll need to reopen or move this on the schedule so you can still finish this problem because it's already past the time you could work on it in WebAssign. But here we have a problem, and we're dealing with work, energy, friction, force, etc. And we have a 92 kilogram box that's being pushed by a 283 Newton force. There is friction that's going to oppose the motion. If the force is greater than friction, the box will accelerate and our final speed will be greater than our initial speed. If friction is greater than our initial force, then the box is going to slow down and our final speed is going to be less than our initial speed. Now, this doesn't happen in this problem, but if there was a problem um, where the final speed would have ended up negative, that's impossible to happen. Once the box comes to a stop, it's the problem is done, and friction is not going to cause it to move in the opposite direction. It only opposes the direction it's moving in. Anyway, our initial velocity is 0.88 meters per second. We're going to push the box for 0.65 meters, and mu k is 0.357. So one of the first things I'm going to do is I'm going to figure out what the friction is based off of the mu k. And so we have the same equation we've been using for friction all along. We have friction equals mu times the normal force. And in this case, because everything is, the applied force is parallel to the floor, we can simply use mg, mass times acceleration due to gravity. And so we ended up with 0.357 times 92 times 9.8, which gives us 322 newtons. Now that's a frictional force, so it'll be negative. A asks for us to calculate the net force, and the net force is the force applied by the person plus the frictional force. The person applied a force of 253 newtons plus the frictional force, which is a negative 322, and we end up with a net force of a negative 39 newtons. Now in WebAssign, it asks for the magnitude of the force, which would be 39 newtons, and then it asks for the direction of the force, and the direction of the force, net force, would be opposite its motion. Then for part B, we're to calculate the net work. Well, the net work, we can calculate this based upon how many joules were exerted. And so we'll take the net force, because work is force times distance. We'll take the net force times the distance moved. The net force was a negative 39 newtons, and the distance was 0.65 meters, so we end up with a negative 25.4 joules. And then for the final part of the problem, we are supposed to calculate what the final velocity is. And to do this, we're going to use our work energy theorem, which says that the net work is going to be equal to the change in kinetic energy. And so working with this equation, we have final kinetic energy minus initial kinetic energy, which would be 1/2 mv squared minus 1/2 mvo squared. We can take the 1/2 m out and we end up with v squared minus vo squared. Then what we'll do is we'll rearrange this for v. To do that, I'll multiply both sides by 2, so I get 2w, divide both sides by m, so I get 2w divided by m. And then I will add the initial velocity squared, and then to get rid of v squared, I'll take the square root of that. So I ended up with the square root of 2 times work divided by mass plus the VO squared. Plugging the numbers in, we have 2 times negative 25 divided by 92 plus 0.88 squared, and then take the square root of that. And we end up with 0.471 meters per second. I hope this was helpful. I'll have another video coming soon on sections 3 and 4.